Good morning, students. In the last class, we focused on glycogenesis. Today, let us move on to the glycogenolysis. Before going into the glycogenolysis, let us recap few that concept which we discussed in the last class, glycogenesis. I think as you all studied that particular glycogenesis in the last class, which I have explained you. So we will recall once. That is, what are all the steps which were involved in glycogenesis? The synthesis of glycogen has happened in 6 steps. First step was exokinase reaction, that is formation of glucose 6-phosphate. In the second step, we saw phosphoglucomutase reaction, that is conversion of glucose 6-phosphate to glucose 1-phosphate. And in the third step, we saw UDP glucose synthesis. So the UDP glucose synthesis, the UDP glucose which was synthesized, it was acting as a vehicle or the carrier molecule of the glucose for the budding of the glycogen molecule. And in the fourth step, we saw the glycogen primer, that is in the glycogen depletion condition, where the protein which was acting as a glycogen primer and which has helped in the initiator, that is by adding up of the glucose molecule by the enzyme glycogen synthase, that is glycogen initiator synthase. And in the next step, elongation of the chain was happened, where the in the elongation of the chain we saw that particular glucose molecules was added up by the glycogenin molecule, and as itself now it itself started adding up of glucose molecule, free glucose residues. As well as in the next fifth step, we saw the branching of the particular enzyme, that is the branching enzyme amylo alpha 1,4,1,6 transglucosidase, which was helped in creating the new branch with the alpha 1,4 glycosidic bonds with the glucose molecules. So these were all the steps which we discussed in glycogenesis. So now let us move on to the next topic, that is glycogenolysis. So what do you mean by glycogenolysis? That is nothing but the once after the synthesis of glycogen, it has to be broken down. When the body is in demand for glucose molecule, this glycogen is going to break up into glucose. So the degradation of stored glycogen in the muscle and the liver, which will result in glycogenolysis. So the degradation of glycogen, which is not a reversible process, where the set of the enzymes, independent enzymes which are present in the cytosol, carry out glycogenolysis. So this glycogen is degraded by breaking up of alpha 1,4 and 1,6 glycosidic bonds. So now let us see the action of glycogen phosphorylase enzyme. So what it does, the glycogen phosphorylase. The alpha 1,4 glycosidic bonds from the non-reducing ends, we have already discussed in the last glycogenesis. I have showed you the slide with the non-reducing end and reducing end. I think you might have understood. Okay. The alpha 1,4 glycosidic bonds from the non-reducing end are cleaved sequentially by the enzyme glycogen phosphorylase to yield glucose 1-phosphate. So you can see in this slide, so how this release of glucose 1-phosphate which is going to happen, where the glycogen phosphorylase is acting on the non-reducing end, you can see the formation of glucose 1-phosphate. So this always acts on this glycogen phosphorylase always acts on the non-reducing end of the 1,4 glycosidic link, which will be cleaved by this phosphorylasis. So phosphorylasis means that is breaking up of that is particular phosphate ester of the glucose 1-phosphate with the retention of energy potential. So this process is called as phosphorylasis. This is going to continue until 4 glucose residue, which is going to remain on either side of the branching point, that is alpha 1,6 linkage. So on either side of the branching point, that is called as alpha 1,6 glycosidic link. So that particular glycogen which is so formed is known as limit dextrins. These are called as limit dextrins, which cannot be further degraded by the same enzyme, that is glycogen phosphorylase. So in the which cannot be further degraded by glycogen phosphorylase. So the next enzyme comes to the picture, that is action of, you can see the action of debranching enzyme. What it does, the debranching enzyme. So the branches which was created, the branch of the glycogen, are cleaved by two enzyme activities, which are mainly these two enzyme activities are present on the single polypeptide chain. So it is present on single polypeptide, which is nothing but this particular debranching enzyme is a bifunctional enzyme. So where this bifunctional enzyme, where the glycosyl transferase, that is oligo alpha 1,4 glucan transferase activity, it removes a fragment of 3 to 4 glucose residues attached at a branch and transfers them to the another chain. That is the particular this enzyme which will help you in removing a fragment of 3 to 4 glucose residues which is attached at the branch point. You can see in this link that particular branch point which was linked that in glucose residues which transfers them to the another chain. That is the action of the debranching enzyme. So this particular transfer of 3 or 4 glucose residues to the another chain. So you can see here that particular alpha 1,4 linkage, alpha 1,4 bond, one alpha 1,4 bond is cleaved and the same alpha 1,4 bond is made at different place. You can see, so the same alpha 1,4 bond which is cleaved there in this slide, so the same alpha 1,4 bond is going to be happened in the say different places. The same alpha 1,4 bond is made at different places. So this amylo alpha 1,1,6 glucosidase enzyme, this amylo alpha 1,6 glucosidase enzyme breaks the alpha 1,6 linkage. You can see in this debranching enzyme where alpha 1,6 that is debranching enzyme is called as alpha 1,6 glucosidase, which is going to break the alpha 1,6 bond at a branch with a single glucose residue. You can see this single glucose residue will be formed. The single glucose residue and releases a that is free glucose molecule. So the remaining molecule of the glycogen is again available for the action of the phosphorylase and debranching enzyme. Both are going to act now. So this remaining molecule of the glycogen is available for the action of both the enzyme, that is phosphorylase and debranching enzyme, which is going to repeat the reaction again. So these two enzyme activity which is going to repeat the reaction again. So you can see here through the combined action of this glycogen phosphorylase and debranching enzyme, glucose 1-phosphate and free glucose which are going to be produced in the ratio of 8:1. These are going to be produced in the ratio of 8:1 by the action of the glycogen phosphorylase and debranching enzyme. So here the glucose 1-phosphate which is converted into glucose 6-phosphate by the action of the enzyme phosphoglucomutase. So this is going to get converted by the action of the enzyme phosphoglucomutase, where you can see the particular fate of this glucose 6-phosphate depending on the tissue. That is hepatic glucose 6-phosphatase, which is further hydrolyzing this glucose 6-phosphate molecule to glucose molecule, free glucose molecule. So this glucose molecule which is going to release into the bloodstream. So the muscle and the brain will not release the glucose to the bloodstream because muscle tissue and the brain tissue does not contain this enzyme glucose 6-phosphatase. So it can provide only ATP for the muscle contraction via glycolysis. So whereas the liver and the kidney and the intestine which contains this enzyme glucose 6-phosphatase, which is helpful in cleaving glucose 6-phosphate to glucose molecule. So you can see only in the liver, kidney and intestine, but it will not be present. This glucose 6-phosphatase activity of the enzyme will not be present in muscle and brain. So this particular where glucose 6-phosphate which is produced by glycogenolysis in the peripheral tissues, it is used up for the glycolysis so it is going to enter into the glycolysis, whereas the major storage organ, that is liver, which will store the glycogen molecule, it will provide the glucose into the circulation which will be further utilized by the various tissues. So you can see in this last two slides how this particular action of the enzyme is going to happen. So the glycogen first will be acted upon by glycogen phosphorylase enzyme. It will release the glucose 1-phosphate. So it is provided where the inorganic phosphate is provided. So it will release glucose 1-phosphate. So the limit dextrins which are formed, these are the limit dextrins, and this limiting extremes which are acted upon by debranching enzyme, that is transferase activity, which will help you in the transfer of 3 or 4 glucose residues, and the breaking up of the alpha 1,4 glycosidic bond and the formation of the same alpha 1,4 glycosidic bond at different places, which is going to happen. The free glucose molecule which is released, so it is acted upon by debranching enzyme, that is by the action of alpha 1,6 glucosidase activity. So where further action which is going to happen by phosphorylase enzyme. So the combined action which will be present in the single polypeptide chain, that is glucose, glycogen, phosphorylase, and as well as the debranching enzyme. So next will be glucose 1-phosphate. So this glucose 6-phosphate, glucose 1-phosphate is getting converted into glucose 6-phosphate by the action of phosphoglucomutase action. So this glucose 6-phosphatase, as I told you, this glucose 6-phosphate is entering into the glycolysis, but this glucose 6-phosphatase which is present in the liver, so it will be acted upon this molecule which will release you the glucose. Synthesis of glucose will be formed from the glycogen. So I think you have understood. So this completes the glycogenolysis. In the next class, we will move on to the glycogenesis and glycogenolysis regulation and its disorders. Thank you.